So the quiz is on 6.1 and 6.2. 10 questions. You will have sometimes, always, and never questions. So be ready for those. Know the definitions and the theorems and how they would apply for a sometimes, always, or a never question. The rest of the questions other than those are free response. So these are the only multiple choice questions because the answer is either sometimes, always, or never. The rest are all free response. They're calculation questions. Now, be able to write an equation for the perpendicular bisector. So in other words, like the example I did in the 6.1 notes, and just like number 9 in the homework. Be able to do a question like that. Also be able to do a question like last night's homework, like number 4, where I'm going to ask you to find the coordinates of the circumcenter. So we did it in the notes, we did it in the homework. It's not in the warm-up, these two questions, but it was in both the notes and in the homework. So be able to do questions like these, in addition to any other examples from your notes, homework, or these warm-ups, or the quiz review. Also, we are going to let you use your TI-30XIIS for this quiz. If you forget your calculator, you can still take the quiz without it, but this is going to be my opportunity to make sure that everyone has the appropriate calculator for when we start the trigonometry. Okay, so in 6.1, this is where we learned about perpendicular bisectors and angle bisectors. So first we learned about perpendicular bisectors, and we learned that any point that is on that perpendicular bisector will be equidistant from the endpoints of the segment that was bisected. So in this particular picture, the segment that was bisected is segment AC here. And I can tell that it was bisected by a perpendicular segment because of the right angle here and because of the two congruency marks. So we learned the theorem that stated that any point on this perpendicular bisector is going to be equidistant from the endpoints of the segment that was bisected. So that tells me that segment AB here is going to be congruent to BC. So in order to find the length of AB, I need to first find the value of x by setting AB equal to BC. So 4x minus 7 is equal to 3x plus 1. It doesn't matter if you put the 3x plus 1 first on the left side or the right side, it doesn't matter. We're just moving our x's together and then our constants. So 4x minus 3x is x. Then I'm going to add the 7, and x equals 8. Now, when you're taking this quiz, read the question. See if I want you to stop at just what x equals, or find the value of something. In this case, it wanted AB. And remember, AB was the 3x plus 1. So I'm going to take my newly found value of x and plug it in. So 3 times 8 plus 1 gives me 24 plus 1. So the length of AB is 25. I'm looking for exactly the same thing in number 2. And number 2 is set up exactly the same way. I've got a perpendicular bisector here. I can tell it's perpendicular by the right angle and that it bisected segment AC because of the congruency marks. So again, any point on that perpendicular bisector will be equidistant from the endpoints. So that tells me again that AB is congruent to BC. So to find the value of x, I am going to set AB equal to BC, solve for x, subtract, divide, and x equals 7 over 2. Fractions are fair game on the quiz. Now what I'm going to do is it didn't ask me to find x, it wants AB, And remember, AB equaled 7x. So again, I'm going to take my newly found value of x. I'm going to plug it in. And I get 7 times 7 over 2. I can make my whole number 7 a fraction by putting a 1. And the length of AB is 49 over 2. I will accept that. You can also make it a mixed number or a decimal. This was working with perpendicular bisectors. 3 and 4, we're going to be looking at angle bisectors. So for number 3, this time it wants me to only find the value of x. So I'm going to zoom in here. And I learned that when we have an angle that was bisected, so this angle has been split, and I can tell that it was bisected because of these equidistant segments to the sides of the angle that was bisected. So because these are equidistant, they've got the right angle and the congruency marks. So I know that now that this piece of the angle, 3x plus 4, is congruent to 4x minus 8. So to find the value of x, I'm going to set those two expressions equal to each other. So 4x minus 8 is equal to 3x plus 4. What I'm using here is the converse of the angle bisector theorem. So I'm going to subtract 3x. X minus 8 equals 4. Add the 8. And x equals 12. And that's all they asked me to find. It didn't ask me to find the angle measure, so I stop right here. For number 4, notice I can tell that this angle here was bisected because of these congruency marks here. So then that tells me that these segments here that are going to the side of my angle are equidistant because they've got the congruency marks. And remember, a distance is always going to be indicated with a right angle. So this 4x plus 10 is equal to 90. I'm going to subtract 10. 4x equals 80. Divide by 4. And x equals 20. So in 6.2, this is where we learned about the points of concurrency of the perpendicular bisectors and the angle bisectors. So in this example, it says in the diagram, the perpendicular bisectors of triangle ABC meet at point G. They want us to give the name for point G. What is this name of the point of concurrency of G? What's it called? Circumcenter. Beautiful. So G is the circumcenter. And we learned the circumcenter theorem, which stated that from that point of concurrency, I have equidistant segments to each of the vertices. So this segment coming from G, going to C, going to B, going to A, these are all going to be equidistant congruent segments here. So this would be 1, 2, I could put 2 markings. Now the perpendicular bisectors are going to be all the little segments with the right angles. So all of the blue lines, these are going to be my perpendicular bisectors. And notice point D, point E, and point F, these are all midpoints. Because remember, the perpendicular bisector is going to hit at the midpoint of the side of the triangle. The perpendicular bisectors in this picture are not congruent segments. However, remember, because E and D and F are all midpoints, that's why AD here is congruent to DB, and then BE would also be congruent to EC, and AF is congruent to FC, because all of these points right here are midpoints. So my first question here, after naming the circumcenter, is to find the length of EC. And EC, I can see, since BE is 5, so is EC, because E is the midpoint. The next thing they want me to find is GC, and GC is that equidistant segment to the vertice. So since BG is 7, so is GC, and so is AG. They had given me 7 here. So questions on the quiz are going to be this easy if you understand the theorems. Some of the questions are just going to have numbers like this. You won't have to solve for an X. And then other questions will be like some of the questions we did in the 6-1 warm-up, where we have to set the expressions equal to each other. So for this one, in this diagram, the angle bisectors of triangle XYZ meet at point D. What is point D called? What is the point of concurrency for the angle bisectors? The incenter. So point D is the incenter. And remember, the incenter is going to be equidistant from the sides. So in this picture, all of the red lines are my angle bisectors. They're going to the vertices. All of the blue lines, these are my equidistant segments. They're not perpendicular bisectors. So the red are the angle bisectors. The blue are the equidistant segments that are going to each of the sides from that incenter. So the blue are the equidistant segments from the incenter to the sides. Sides of the triangle. So they're telling me in the problem that the length of AD here is 10. And they want me to find the length of DB. Well, DB is that equidistant segment from the end center to the side. So if AD is 10, DB is 10, and so is DC. So DB equals 10. So again, just be able to apply the theorems based off of these points of concurrency. So the quiz review that is posted on Canvas, this whole page actually covers 6-1 to 6-3. However, your quiz is only 6-1 and 6-2. So before you click on the document to open it, the instructions say to only do 1 through 8. 9 through 14 are for 6-3. Do not focus on those. If you notice, number 5 is missing. Okay, number 5 was asking you to find the coordinates of a circumcenter of either an acute or an obtuse triangle. What I want you to focus on is finding the circumcenter of a right triangle. And that's why I left number 4. And the assignment has the solution file. So be able to, in addition to your notes, your homework, also be able to do these practice problems and the warm-ups as well.